Welcome viewers to a What Tradies Want Tradie Tough Test. I'm Marcus Hucker. Today we're looking at something that I think straight out of a science fiction movie, plasma cutters. Traditionally only been available in heavy industry. Thanks to a few companies on the leading edge of thermodynamics, they've brought them down to size and weight and made it available to the common tradesperson. I've got with me today Bryan Eveleigh from CIGWELD, and he's going to help us conduct a few tests. But firstly I want to ask you, Bryan, what is plasma cutting?
Technology behind the process is all about a gas ionisation, creating an electric arc, and then the restriction of the airflow blows the molten metal through the material, and that's actually what's doing the cutting.
Okay, and it runs at really high temperatures from what I understand.
Anywhere from 15,000 to 35,000 degrees C, so it's certainly a much more economical process.
And one thing I noticed in the brief is that it also cuts a greater variety of materials.
Anything from mild steel, aluminium, stainless steel, brass, copper, cast materials, and even hard face wear plate.
All right, well we've got a few tests to put together. I think we should get to it. Let's get into it, mate.
Yeah, sounds good. Okay, just introducing the Cutmaster 10. This machine's a 240 volt 10 amp machine, so it plugs into your general power point at home. So that's the flexibility and where technology's gone with the machine now. This is the biggest brother of the Cutmaster series, so this machine here is 3-phase, capable of cutting 40mm plate. So again, you can unplug the hand torch off the front of the machine and you can plug in the machine torch, as simple as a quick changeover. Okay, now we're actually going to cut some mild steel with the plasma cutter, starting with 6mm plate. We're going to cut out a shape, and the actual shape we picked is a star, so it's going to show how quick and clean we can cut into corners and outside corners and so forth of the plasma versus oxy. Now we're going to do the same thing with 12mm plate with the plasma cutter, and this will actually show you piercing through the material. So we're piercing holes as well as cutting out a smiley face shape. We're going to do the same thing with 20mm plate now. So again, showing the plasma cutter versus the oxy process in piercing as well as cutting a shape out. Okay, so with the oxyacetylene process, we cut some 5mm plate, and you can physically see the heat affected zone there on the cut versus what we got against on the plasma cutter. So certainly much more heat input. Now the 12mm plate, we pierced a hole, and you can certainly see the massive difference there with the piercing and heat input on that as well. On the 20mm plate, we cut the V in the end of the material, and you can see the heat affected zone there versus what it was with the plasma. Okay, on the stainless, the plasma process did a nice, clean, quick cut with very little heat input and able to pick the material up without burning your hand. With the oxy process, the point was proven that it can't be cut. It just melted the material away and put a massive heat affected zone there. On the aluminium material, again, a nice clean cut on the aluminium on the back end with fast travel speed, very little heat input. And on the back edge with the oxyacetylene process, no cutting, it just melted the material away. We had the plasma gouging process, gouging through a weld which in a case could have a crack in it. We're gouging that out to put a new weld in there. The plasma process was a lot cleaner, faster, and you could press the trigger and start travelling straight away. With the oxy process, we press the trigger, got to wait for it to heat up before we can start travelling, so much more heat input and can affect the grain structure and integrity of the material.
Well, Bryan, that was truly impressive. We went through a range of cuts, and what really stood out was the cleanliness of the cut of the plasma cutter, the speed at which it went through, its accuracy. But really for me, it was the ability to cut through aluminium and stainless steel, whereas the oxy obviously wasn't able to do that. Tell me, mate, what applications could we expect to have the tradies out there use this for?
Well, it's anything from really a home handyman making a box trailer or cutting rust out of a box trailer. He's not getting no heat input into the material, and shows how clean the cut is there on the material. Right through to the heavy industry. You know, stainless steel guys making balustrades, boats, tinnies, anything like that, that type of thing.
Okay. And it's important to note that a plasma cutter doesn't actually make a oxyacetylene redundant. It still has its place.
Absolutely, because the oxyacetylene process is capable of cutting, welding, heating and gouging. Where the plasma process, that's all about cutting and gouging only.
All right, great. Well, thanks mate for coming in and joining us today. I hope you guys have enjoyed it as well, and we'll see you next time for What Tradies Want Tradie Tough Test. Now, if you want to get your hands on one of these products, go to the CIGWELD.com.au website and follow the links and look for plasma cutters, basically. Is that right?
Yeah, that's right. Yeah, absolutely.
Okay. Thanks again and see you next time.
Thank you.